Welcome to the Diels Alder reaction at Nazareth College. This is one of the most powerful tools in organic chemistry. It is a concerted, thermally allowed 4+2 cycloaddition between a diene, shown on the left here, and a dienophile, shown on the right, with the product being a cyclohexene molecule. The reaction can be sped up if the dienophile has an electron withdrawing group, like this ester group, and the diene has an electron donating group. For example, this methyl group. I should mention also that the diene has to be in the S-cis conformation, meaning that the double bonds have to both face the same way. In addition, we will get a mixture of products depending on which way the alkene approaches that diene. There are stereochemistry considerations as well. If your alkene is cis, then your cyclohexene product will also be cis. If your alkene is trans, then your cyclohexene will also be trans. And finally, if your diene is a cyclic diene, then we can end up with a bicyclo compound that can be one of two forms: endo, where your group is closest to the double bond, and exo, where your group is facing away from the double bond. The double bond that I am referring to is the double bond that was created in our cyclohexene molecule. In this lab, we will be reacting malic anhydride and cyclopentadiene. Malic anhydride is a great dienophile because it has two highly electron withdrawing carbonyl groups. Even though we're heading into the lab now, I'm not quite done with the theory. It turns out you cannot purchase cyclopentadiene. You can only purchase dicyclopentadiene. And this is because at room temperature, cyclopentadiene spontaneously dimerizes in a Diels Alder reaction with itself to make dicyclopentadiene. At 150 degrees Celsius, dicyclopentadiene undergoes a retro Diels Alder reaction and becomes cyclopentadiene. So we have to, it's called crack the dicyclopentadiene into cyclopentadiene for use in this reaction. We use a simple distillation apparatus for this purpose. Typically, the instructor would do this for you, but I wanted to show you how it was done. You need to make it on the day of the experiment, so collect 2 mils of cyclopentadiene and set that aside. Now, in a clean, dry 125 milliliter Erlenmeyer flask, place 2.0 grams of malic anhydride and dissolve that in 7.5 milliliters of ethyl acetate, warming it in a warm water bath to get it to dissolve. Once it has completely dissolved, allow the solution to cool to room temperature and place it in an ice bath. Now you're going to take your 2 milliliters of cyclopentadiene in a graduated cylinder and add that to your cold malic anhydride solution. Swirl the solution, leaving it in the ice bath, keeping it nice and cool. Now measure out 7.5 milliliters of hexane. Add that to the cooled flask with your reaction, replacing it in the ice bath, and watch as your product crystallizes from solution. Once the product crystallizes, heat the mixture in a hot water bath to redissolve the solid and allow it to recool to induce crystallization in that same container. Once your crystals form, collect the product by vacuum filtration. Take the final weight of your product, calculate the percent yield. Shown here is the final mass for this experiment. I determined the melting point range to be 162 to 166 degrees Celsius, and here is the IR spectrum for the product. Be sure to assign all important peaks here. Good luck! And now, safety with Jane.
Use proper safety goggles and gloves and complete your experiment in the hood. Dicyclopentadiene can cause headache, dizziness, nausea, and vomiting, and is a flammable liquid and a fire hazard. Maleic anhydride has been observed to cause irritation of the respiratory tract and eyes. Ethyl acetate is highly flammable as well as toxic when ingested or inhaled. Petroleum ethers are extremely volatile, have very low flash points, and present a significant fire hazard. As always, organic waste should be placed in the organic waste containers in the waste hood. Remember, always be safe in the lab. Easy peasy.
There you have it. We did it. We did Diels Alder in the lab. How exciting. Plus, I didn't tell you this yet, this is my all-time favorite reaction. Yay!